Hi, in this video we are going to see about special right triangles. So there are two types of special right triangles. One is 45, 45, 90, a special right triangle, and other one is 30, 60, 90 special right triangle. So what is 45, 45, 90? So whenever we have a triangle, it will have three sides and also it will have three interior angles like this. Okay, here among these three interior angles, if one of the angles is 90°, then the triangle is called right triangle. So what about the remaining two interior angles? If the remaining two interior angles are 45, 45 each, then it's called a special right triangle, and also it is named as 45, 45, 90 special right triangle. Okay, let's consider another right triangle over here. Okay, so this is the right angle. So the one of the interior angle must be 90°. So in the remaining two interior angles, one of the interior angles measures 30°, the other one measures 60°. Then this is also a special right triangle. It is named as 30, 60, 90 special right triangle. So there are two types of special right triangles. So this 45, 45, 90 are the interior angles of the triangle, and here 30, 60, 90 are the interior angles of the special right triangle. Okay, in the next part, let's see how to solve for the lengths of the sides of these two special right triangles. Here we have 45, 45, 90 special right triangle. So, and also it is an isosceles right triangle because two of the interior angle measures are equal. So it is an isosceles right triangle. So isosceles means so two of the sides must be equal. So the two sides AB and BC are equal to the same interior angle measure 45°. That is, AB is opposite to the interior angle measure 45°, and BC is also opposite to the same interior angle measure 45°. Since the two sides AB and BC are opposite to the same angle measure 45°, so the length of AB and the length of BC must be equal. Okay, I assume the length of the side BC is x. What about the length of AB? That must also be x, because both of them, both AB and BC are opposite to the same angle measure 45°. So the lengths of the sides AB and BC must be equal. Okay, so what about the length of AC? Actually, AC is called hypotenuse in this right triangle because the side AC is opposite to the right angle 90°. So the side AC is called hypotenuse. Okay, how do you have to find the length of AC? We can use Pythagorean theorem to find the length of the hypotenuse, because Pythagorean theorem says so the sum of the squares of two legs of a right triangle is always equal to the square of the hypotenuse. Okay, first let me square the hypotenuse. That is AC square equals to it has to be equal to sum of the squares of the other two legs, that is AB square positive BC square. Okay, so AC square for AC we do not know the length. That is what we have to find actually. For AB we have assumed x, so we have x square. For BC also we have x, so it's x square. So AC square equals to x square positive x square will become 2x square. And since our aim is to find the length of AC, we have to get rid of the square. For that we can take square root on both sides. When I take square root on both sides, the square root and square will cancel out. I get AC on the left side. On the right side, 2x square can be written as 2 times x. Okay, inside the square root, whenever two same numbers or two same quantities are multiplied, one quantity will come out. So for these two x, 1x will come out, and inside the square root, we'll have just 2. So now I got the length of AC, that is the length of the hypotenuse of this right triangle. So that is x times square root of 2. Okay, here, it's my advice always we have to remember this stuff. That is like whenever we have 45, 45, 90 special right triangle, so the two legs will have equal in length. So we have to assume x as the length of each leg. Then the length of the hypotenuse will be whatever stuff you have assumed as length of this leg. It has to be multiplied by square root of 2. That is the length of the hypotenuse. So if x is the length of each leg, in 45, 45, 90 special right triangle, then the length of the hypotenuse will be x times square root of 2. Okay, now let us solve for the lengths of the sides of another special right triangle, 30, 60, 90. Here we have 30, 60, 90 special right triangle. Okay, here we are going to see how to solve for the lengths of the sides of the triangle. Okay, here in this triangle, the three interior angle measures are 30, 60, and 90. and the side or the leg which is opposite to the shortest, the smallest angle is the shortest leg. So here BC is the side which is opposite to the smallest angle, smallest interior angle, that is 30 degree. So BC is the shortest leg of this triangle. Okay, I assume X as the length of the shortest leg BC. Then what can be the length of the next longer leg AC? And the hypotenuse is always the longest leg of the triangle, the longest side of the triangle. Okay, anyways, we have to solve for the length of the side AC and the length of the side AB. So how do you have to solve for this one? Okay, so in this way, in this triangle, I assumed the shortest leg BC as X. So to solve for the lengths of the other two sides, what I'm going to do is I'm going to draw another 30, 60, 90 triangle adjacent to this triangle by taking AC as a common side. And also the triangle, the 30, 60, 90 triangle, another triangle that I'm going to draw must be congruent to this one. Okay, so that I'm going to draw a new triangle, 30, 60, 90 triangle adjacent to this one. And I'm going to take this AC as a common side. Okay, so I've drawn another triangle. I have right angle over here, and I have 30 degree angle measure over here, and 60 degree angle measure over here. Okay, I've already told you that I'm drawing this right triangle so that it is congruent to the existing right triangle ABC. I name this vertex as D. Okay, so the triangle ABC, this one, and the triangle ACD, both of them are congruent. So if two triangles are congruent, the corresponding sides also must be congruent. So here BC is the side which is opposite to the interior angle measure 30 degree. So here which side in the triangle ACD, which side is opposite to 30 degree angle measure CD? So CD is opposite to the angle measure 30 degree. Since the two triangles are congruent, the corresponding sides must be congruent. So BC and CD are corresponding sides because both of them are opposite to 30 degree angle measure. If BC is X, then CD also must be X because the two triangles are congruent. Since the two triangles are congruent, corresponding sides also must be congruent. It has to be X. Then what is the total length of this BD? It's 2X. Okay, now let's consider the triangle ABD, the whole triangle. Okay, if I consider the whole triangle ABD, what do I get? Here, this is 60 degree, the first interior angle measure. The second interior angle measure also 60 degree. The third one, 30 plus 30. When I combine these two, this one also 60. So all the three interior angle measures are equal in the triangle ABD. So ABD is an equilateral triangle because all the three interior angle measures are equal. So equilateral triangle means the length of each side of the triangle must be same. Already I know the length of the side BD is 2x. Then what about the length of AD? It should also be 2x. And what about the length of AB? That one also must be 2x. Okay, now what I'm going to do is I'm going to consider only the triangle ABC over here. Now I consider only the right triangle ABC, the original triangle. So in this right triangle ABC, I know the length of the side AB, which is hypotenuse because it's opposite to 90 degree. And I know the length of BC, that is assumed by us, it is X, which is opposite to 30 degree. Now mine is to find the length of AC, this side. Okay, so again we have to use Pythagorean theorem. So Pythagorean theorem means like sum of the squares of two legs of a right triangle is always equal to the square of the hypotenuse. So let me write it over here. So AC square positive BC square. I'm squaring this length, this leg, and this leg. So it has to be equal to the square of the hypotenuse, which is AB square. So for AC, I do not know the length. I have to solve for AC. And for BC, I know the length, that is X. So we'll have X square. For AB, just now I got the length, which is 2X. So I have 2X, the whole square. So AC square positive X square. So here 2 and X are multiplied and we have common exponent. So this common exponent taken separately for each value. So we get 2 square times X square. So AC square positive X square equals to, the value of 2 square is 4 and X square is the same. Okay, to solve for AC square, we have to subtract X square from both sides because I have to get rid of this X square. positive x square, negative x square will cancel out. I get AC square is equal to 4x square, negative x square will become 3x square. And now to get rid of the square over here, I'm taking square root on both sides. So this square root and square root cancel out. I get AC equals to square root of 3x square can be written as 3 times x. And for every two same values multiplied inside the square root, one value will come out. So for these two x, this is 1x will come out. So x times square root of 3. So now I got the length of AC, which is x times square root of 3. Okay, now we have solved for all the three sides of this 30, 60, 90 special right triangle. Now let's recap the stuff what we have discussed so far only in the right triangle ABC. So it's a 30, 60, 90 special right triangle. So first I assume the length of the side BC, which is opposite to the smallest angle 30 degree, as x. Then the length of the side which is opposite to 60 degree, that is AC, should be so this value, I mean the length of the side BCX has to be multiplied by square root of 3, and the length of the hypotenuse AB has to be 2 times of this value, so that is 2x. So we just have to remember this so that easily we can solve the problem. I mean, we can quickly solve any problem which is based on 30, 60, 90 triangle. Okay, so based on the stuff we have covered so far, let's do some problems. Here we have a right triangle ABC. In this right triangle ABC, we have to find the length of the side BC, which is hypotenuse, because it is opposite to the right angle over here. And also in this right triangle, the length of AB is 3 units, the length of AC is 3 units. So the length of AB and the length of AC are equal. So it is an isosceles special right triangle. And here the interior angle at vertex B is 45 degree, which is opposite to the length of 3 units. Then the length, the interior angle at vertex C must be 45 degree, because this is also opposite to the same length 3 units. Now it is a 45, 45, 90 special right triangle. So in a 45, 45, 90 special right triangle, so the two legs will be equal in length, and we will be assuming x as the length of each one of the two equal legs. So if I assume x as the length of the leg AB, then the length of the leg AC also must be x. Okay, then what is the length of BC? It has to be x times square root of 2. So according to the stuff we have covered so far on 45, 45, 90 special right triangle, if x is the length of each one of the two equal legs, then the length of the hypotenuse has to be x times square root of 2. But instead of x, what do we have over here? We have 3. Then we have to plug in 3 for x over here. So then the length of BC equals to, so we have to plug in 3 for x over here, then we get 3 times square root of 2. Here we have a right triangle. In this right triangle, we have to find the value of x. Okay, in this right triangle, this leg and this leg are equal in length, because x represents the length of each of these two legs. Okay, so clearly it's an isosceles right triangle, because the two sides of this triangle are equal in length. And this side represents hypotenuse, because it is opposite to the right angle. Okay, here in this right triangle, since two sides are equal, then the three interior angles must be 90 and 45, 45. Because in any isosceles right triangle, apart from right angle 90 degree, the remaining two angles will measure 45 degree each. So because I'm taking the same angle measure for these two interior angles, because both of them are opposite to the sides of the triangle, which are equal in length. So how can I decide this is 45, this is 45? Because only if I take 45 degree as an angle measure over here and here, then the three interior angle measures will add up to 180 degree. So because in any triangles, we know that the three interior angles must add up to 180 degree. So clearly it's a 45, 45, 90 special right triangle. In this special right triangle, so the length of the two equal legs is x units each. So in that case, what is the length of the hypotenuse? According to the stuff we have covered so far on 45, 45, 90 special right triangle, so the length of the hypotenuse has to be x times square root of 2. So if the length of the two equal legs is x units each, then the length of the hypotenuse has to be x times square root of 2 in 45, 45, 90 special right triangle. But already we know the length of hypotenuse, that is 5. So instead of x times square root of 2, we have 5. So we can equate x times square root of 2 and 5 because both of them represent the length of the hypotenuse. Okay, here we have to solve for x in this equation. For that, I divide both sides by square root of 2. So the square root of 2, square root of 2 will cancel out. I get x equals to 5 over square root of 2. Here, the denominator is square root of 2. It's an irrational number. Usually, when we give our answer, we will avoid an irrational number at the denominator. So to rationalize this denominator, I have to multiply both numerator and denominator by square root of 2. So x equals to 5 times square root of 2 over, when I multiply square root of 2 and square root of 2, it will just become 2. So I got the value of x. So x equals to 5 times square root of 2 over 2. Okay, let's look at another problem. Here I have a right triangle ABC. In this right triangle, we have to find the length of the side AB and the length of the side AC. Okay, here in this right triangle, the shortest leg is AB, which is opposite to the smallest angle, 30 degree. Okay, according to the stuff we have covered so far on 30, 60, 90 special right triangle, we will assume x as the length of the shortest leg, which is opposite to 30 degree. So here in this case, we have to assume the length of the side AB as x. Then the length of the side, which is opposite to 60 degree angle measure, will be x times square root of 3. Then the length of the hypotenuse will be 2x. Okay, here already we know the length of the side BC, that is 5. But according to our assumption, the length of the side BC is x times square root of 3. So the two stuff, x times square root of 3 and 5. So both of them represent the same thing, that is the length of the side BC. So we can equate them and we have to solve for x. Once we get the value of x, so that is the length of AB, and when I multiply the value of x by 2, so that will give us the length of AC, which is the hypotenuse of the given right triangle. Okay, let's solve for x in this equation. For that, I'm going to divide both sides by square root of 3. So the square root of 3 will cancel out. I get x equals to 5 over square root of 3. Here the denominator is square root of 3. It's an irrational number. So usually we don't keep the denominator as an irrational number. So I have to rationalize this. For that, I have to multiply both numerator and denominator by square root of 3. So when I do so, I'll be getting 5 times square root of 3 over square root of 3 times square root of 3 will become just 3. So I get x equals to 5 times square root of 3 times 5 times square root of 3 over 3. Okay, now let's find the value of 2x. 2x means I have to multiply this one by 2. So 2 times 5 times square root of 3 over 3. So 2x equals to 2 times 5 is 10. 10 square root of 3 over 3. Okay, the length of the side AB is 5 square root of 3 over 3. The length of the side AC is 10 square root of 3 over 3. Okay, let's look at one more example. Here I have a SAT math problem. Actually, this problem can be solved using the stuff we have covered on 30, 60, 90 special right triangle. Okay, let's go over the question. In rectangle ABCD above, E is on DC, F is on BC, DE equals to 6, FC equals to 1. If angle A is trisected, it is divided into 3 equal angles by AE and AF. What is the length of BF? So they ask us to find the length of BF. And the question says the angle measure A is trisected. That means it has been divided into 3 equal angles by the line segments AE and AF. In rectangle, we know that each vertex angle will be 90 degrees. That is right angle. So here we have right angle, here we have right angle, here we have right angle, and here also we have right angle. Right angle means it's 90 degree. So the 90 degree angle measure we have at the vertex A is trisected. That is, it has been divided into 3 equal angles by these two line segments AE and AF. If 90 degree is divided into 3 equal parts, then each part will be 30 degree. So here it's 30, here is 30, here it's 30. Okay, already we know that this is a vertex angle at the vertex T, so 90 degree. And what must be the measure of this angle over here? It has to be 60 because ADE is a triangle. In a triangle, the 3 interior angles must add up to 180. We know that this is 30, this is 90, 120. So to get 180, we need 60. 60 has to be the measure of this angle. So clearly, ADE is a special right triangle. That is 30, 60, 90 special right triangle. Okay. Already we know that in a 30, 60, 90 special right triangle, the side or leg which is opposite to the smallest angle 30 degree has to be assumed as x, according to the stuff we have covered so far. Okay, so the length of the shortest leg, which is opposite to the smallest angle 30 degree, is assumed as x, then the length of the side, which is opposite to 60 degree angle measure, has to be x times square root of 3. And the hypotenuse is 2x. Actually, it is not required in this problem. Anyways, so here, already we know the length of the shortest leg DE, that is given in the question itself, that is 6. But we have assumed the length of the shortest leg DE as x. So for x, we have 6. So x is equal to 6. Then if I plug in x is equal to 6 over here, it will become 6 times square root of 3. So the length of AD is 6 times square root of 3. In any rectangle, opposite the lengths of the opposite sides are equal. So whatever length we have for AD, the same length we'll have for BC. Already we know that we got the length of AD, which is 6 times square root of 3. Then the length of BC also must be 6 times square root of 3, because opposite sides are equal in length in any rectangle. So here we have BC equals to 6 times square root of 3. But my aim is to get the length of BF. That's my target. That's the target of the question, BF. So if I want to get the length of BF, I have to subtract this FC from the total length BC. So BC negative FC. So what is the length of BC? That is 6 times square root of 3. The length of FC is given in the question itself, that is 1. So the length of BF is 6 square root of 3 negative 1. So the correct answer choice for this question is option D.